let's talk about the segment addition postulate. Segment addition postulate is just that. We're taking two segments and adding them together to make a larger segment. Here's an example here, AB. So the line starting at A and ending at B. Okay, if we add that, just wondering if I can change my color here, to BC, so BC is the line starting at B and ending at C. What they're saying is if we take those two segments and add them together, we get this entire segment from A to C, which makes sense. If the distance from A to B were 2 and the distance from B to C were 5, we can easily see if we had a stick length 2 and a stick length 5 and put them together, what length do we have? We have 2 plus 5, or 7. Okay, that's basically what we're working with the segment addition postulate. It's not what we're used to looking at, so it's a little foreign at first, but we're going to do okay. All right, so here is an example that they're asking us to work out. If BC is 2 times the length of AB, what is AC going to be? Now notice we have that same picture. We have two segments next to each other that make up a larger segment. We know that whatever AB is plus whatever BC is going to give us the distance from A to C. But we have to start with the information they gave us. They said that BC is 2 times the length of AB. So BC is equal to 2 ABs put together. Let's put in our information that they gave us. We know that AB is a length of X. So I'm going to replace AB with an X. We know BC is 30. Let's use that to find out what X would have to be. Now you may have figured that out in your head already, and that's all right. If not, we can use algebra. 2 times X, to remove that, we do the opposite of multiplying by 2. We divide by 2. And we get X is 15. So we know the length here is 15, and we can answer our question. What is the length from A to C? So if we start down here at A and go all the way to C, how far have we gone? We've gone 15 plus the 30, or 45. All right, here's another example. It says that DE is 1/2 that of EF minus 35. What's the best representation for the length of DE? Okay, well, let's take a look. So they didn't ask us to solve it. We may do it anyways and just solve it out, but they just want us to represent it as a equation. So let's look at this. DE is, when you see the word is, that's where your equal sign goes. So far we have that DE equals 1/2 of EF minus 35. Okay, there we have it. DE is 1/2 of EF minus 35. Now if they asked us to solve this for X, we could. We replace our values. We know DE is our X. We know EF is 84. And we go from there. So 1/2 of 84, or 84 divided by 2, would be 42, is half of 84. And then we take that 42 minus 35. And we get X is 7. Okay, but when you just want a representation, this would be a good representation for DE.